In this video, we'll explore the TiCDC component of the TiDB database system in detail. We'll show you how to set up change feeds step by step. We're starting with an existing cluster that's already running. If you'd like to know how to set up a test instance to follow along with this tutorial, please check out the other videos on this channel. Our current setup includes 4 separate virtual machines that are running all 3 main components of TiDB. These are the 4 instances you can see here. We also have a control node with TiUP installed. Everything is running on the same private network. The only public exposure we have right now is access to the TiDB dashboard. To make our demonstration more interesting, we're going to create a RedPanda instance. RedPanda will serve as our Kafka-compatible asynchronous message queuing layer that we'll use with the Change Data Capture system. Since this is quite straightforward and quick to set up, we can pick a pretty small machine for this purpose. A standard S2 machine size should be sufficient for our needs. For the operating system, we really just need something that can run Docker effectively because we're going to use a Docker Compose-based installation. Something like Debian or Ubuntu would be a good choice here. We're going to skip disk backups for this demonstration, and we only have one network available, but you want to make sure that this RedPanda instance is accessible and running alongside your existing TiDB system. Now, although we would typically use infrastructure as code tools for this kind of setup, we're going to do a more manual provisioning of this RedPanda instance so you can see every step of the process. Let me take a very quick moment to sketch out what we're talking about here. The architecture we're building works like this. We have our TiDB cluster, and we're going to have that cluster send change events to RedPanda. The specific component that handles this data streaming is called TiCDC, where CDC stands for Change Data Capture. We get to stream all the changes from the cluster to RedPanda, Kafka, or whatever other service we choose. This is the whole architecture and the whole idea behind what we're building today. This is the basic idea. As users or perhaps servers interact with our TiDB cluster, those changes are reflected and streamed to RedPanda. Following the RedPanda Getting Started guide, we want to make sure we have Docker installed, which it does not look like we have on our new machine. I'm sure we also don't have Docker Compose installed yet. So we need to copy the standard installation commands. First, we need to set up the apt repository, which is basically the first block of commands here. Then we install both Docker and Docker Compose. Now let us test that installation with the Hello World container to make sure everything is working properly. Our installation seems to be looking good. We should hopefully also have Docker Compose available now. It looks like Docker Compose is still not showing up, so let us install it with one more command. Alright, now we've got the main prerequisites covered for our RedPanda instance. We can go ahead and run the commands from the RedPanda Quick Start Guide. Basically, we're going to create a directory, pull down some files for the Docker Compose setup, and then run it to bring up our RedPanda cluster. A Docker ps command should hopefully show us some nice running containers, and indeed that is the case. Let us go ahead and check out this RedPanda console that should be running on port 8080. To do that, we'll want to fine-tune our firewall rules. Right now, we're allowing port 2379 access on any instance, So we're going to go ahead and refine that existing firewall rule so that we're only allowing access to the TiDB dashboard instance that we want. Let us create a specified target tag and add TiDB dashboard as the networking tag that we're going to allow access to. We probably also don't necessarily need this old Grafana firewall rule, so let us delete that. On our compute engine page, we'll add that network tag for the TiDB dashboard, and we don't even have to turn down our virtual machine to make that change. So that tag is now running on the first of our 4 TiDB instances. Now, back to our main work here with the firewalls, let's add a new firewall rule for RedPanda. This will allow public access, but let us just keep it constrained to the console port for now. Again, we'll need to add that networking tag to our compute engine virtual machine for RedPanda so that this firewall rule applies properly. All right, so refreshing our page here for the TiDB dashboard, we're still seeing that working nicely. So that firewall rule seems to be working smoothly. Now let's grab the external IP address of our RedPanda instance and see if we can access it as well. It should be available on port 8080, and indeed that looks like it is working. Please note that we're not doing this in a super secure way for this demonstration. This is just running on HTTP without encryption or other security measures that you would want in a production environment. So we can see that we basically have 3 RedPanda brokers, all of which are online. We have a few topics with 3 replicas each, and there's some demo data already in the system. While we're here, let's go ahead and change that super user password. The randomly generated one is probably fine to keep. We'll keep running with the same 256-bit SASL mechanism for authentication. Just to be a little bit more clear about what Change Data Capture is, it's basically a design pattern for capturing every single data modification that happens in your database. This includes every insert, update, and delete operation. Since TiDB is MySQL compatible and is a structured, schema-based SQL database, those atomic operations are what we're going to get as our stream of changes. TiCDC is a highly integrated part of the TiDB ecosystem for streaming these changes. It's engineered around high data reliability, high service availability, horizontal scalability, and low latency. All right, so we've got our endpoint configured now, and this is where things start to get interesting. We can now start to direct change feeds to this RedPanda instance. Let's use the TiUP cluster display command to make sure that we already have this component running in our cluster. It looks like we don't already have TiCDC running, so we're going to go ahead and add that as a component to our cluster. Our required configuration for setting this up just needs to start with the CDC servers block, and we need to provide a host. Since we're not already running TiCDC, we just need to pick a host for it. We can use the internal IP address, and we'll just run this on the first node without needing to provision another server. We'll leave things like the port and directories at their default settings. We use the TiUP cluster scale-out command and provide our configuration file to add the TiCDC component to our existing cluster. Just like that, our TiCDC component is up and running. We can check out that component with the TiUP cluster display command, and we can see it listed here with the status of up, so we're looking pretty good. Now the idea here is that for our database that is running, we add what's called a change feed. A change feed is basically a replication task. We want to replicate all changes from specific tables to a certain destination. In TiCDC terminology, a capture is a running TiCDC process, typically one per node, and a sink is simply the downstream destination where your change data will be sent. Let's go ahead and log into our TiDB instance using a MySQL client. We're going to create a database and table just for the sake of demonstration. Let's call this database Invoices, and we'll create a table with some basic example invoice information. This is simple, but will definitely help us demonstrate how the change data capture works. For the replication, we need to introduce the TiCDC CLI tool. We can probably get this binary directly, but I suspect we can use TiUP to install it as well, which will keep everything under the TiUP umbrella for consistency. And then we can do things like create our change feed using this tool. We'll use the TiUP CDC CLI change feed create command. We want to specify a server, and that is going to be basically the IP address of our TiCDC node, which we installed on our first TiDB node. Let's call this change feed invoices to RedPanda and provide a sync URI. This is where we use that Kafka-compatibility of RedPanda. To get the correct connection details, note that we're going to need to provide the IP address of our RedPanda instance. Let's use the internal IP address, and I believe we will point to port 9092, which is the standard Kafka port. We're also probably going to need a configuration file for our change feed. Let's go ahead and create that configuration file. We'll keep this pretty simple. We just need a filter section which tells TiCDC which data to replicate, and then some rules. Let's configure it to replicate only the invoices database. Now note that if the topic does not already exist in RedPanda, this invoices topic, TiCDC will actually attempt to create it for us automatically. So we probably don't have to do any additional RedPanda configuration work here. We can go ahead and try to create this change feed. Alright, when TiCDC tried to connect to our RedPanda instance on port 9092, it threw an error. So let's go ahead and check out our RedPanda setup to make sure everything is running correctly. It looks like everything's running smoothly from our Docker Compose setup on the RedPanda server, at least at first glance. However, we did see a connection error on port 9092 for external connections. Here's something interesting about RedPanda's port configuration. When we check the external connections, we find that we can connect to the first broker on port 19092, the second broker on port 29092, and the third broker on port 39092. If we go to the overview section, our first broker is currently the controller of the cluster, so it's basically the main one. Let's try connecting to port 19092 instead. We'll make a quick tweak to our configuration and attempt to create that change feed again. It's still failing, but we can use the TiUP CDC CLI change feed list command to see what's currently running. We'll need to specify the server since our TiCDC service is not running on our control node, but rather on one of our data nodes. Okay, so we have nothing listed there, which means no change feeds are currently active. It probably shouldn't matter, but let's try removing the HTTP// prefix from our server argument, just to be thorough and see if that makes any difference. Indeed, we should be accepting connections on all those ports that RedPanda is advertising. However, it's now showing an unhealthy message, which is a bit concerning. In our logs, we also see some failed authentication errors. If authentication is indeed the issue, that would be a pretty vague and frustrating error message, but let's test this theory. Since we have authentication enabled on our RedPanda instance, let's provide both the SASL mechanism and our username and password and see if that changes anything. We're still getting connection issues. Of course, we can also do some classic network connectivity tests. A quick ping command confirms that we actually have network reachability between our TiDB and RedPanda instances, so routing is not the problem. But here's a twist. The weird localhost IPv6 address that is popping up in our error messages could mean something odd is happening with the network configuration. Let's try using single quotes around our connection string in case it is just some bash shell quirk that's causing problems. It is possible that we're making the initial connection successfully, but when TiCDC tries to create a new producer connection, it defaults back to localhost. That makes me think the advertised Kafka API configuration is not set up correctly on our RedPanda instance. Let's jump into our Docker Compose configuration and inspect the RedPanda setup more carefully. Looking at the advertised Kafka address in our Docker Compose file, I actually see localhost configured there, which is probably not what we want for external connections. We should be using the internal IP address of our RedPanda machine instead. So let's make that update. Let's even do a quick grep command to find every instance of localhost in the configuration file. While minimal changes are okay for some settings, for the advertised proxy and advertised Kafka addresses, those definitely need to be updated to use the proper internal IP address. That is probably all we really need to change. So here's the advertised Kafka address that we'll swap out for the internal IP. We should update this configuration for all three RedPanda brokers that are running on this machine, since they're all configured in the same Docker Compose file. Since we're mounting volumes from the host machine in our Docker Compose setup, changing those configuration settings should not affect things like our admin password when we recreate the containers, but let's double check that in a moment after we restart everything. Unfortunately, we're now hitting an issue with what I think is just one of our RedPanda configurations. Let's see if there's a typo or misconfiguration somewhere in the Docker Compose setup. Alright, looking at the top section of the RedPanda configuration blocks, this actually looks pretty solid. The connection configurations here look correct, so let's look a bit closer and figure out what might be going on with our setup. After restarting our containers, it looks like we have a new broker controller leader, and the containers appear to be healthy, so let's give our TiCDC connection another try. Instead of letting the change feed automatically create the topic for us, where little configuration gremlins sometimes sneak in and cause problems, we'll pre-create the topic manually in the RedPanda console. We need an invoices topic, and once that's in place, the change feed can pipe events straight into it without any issues. The topic has been created successfully. Now let's run a quick TiUP CDC CLI change feed list command to confirm that our change feed configuration is working properly. There it is, and the state shows as normal, which means everything is functioning correctly. Here's where it gets interesting. We'll jump back into our TiDB database, insert a row into our invoices table, and watch the change stream light up in real time. Let's insert a record into our invoices table. We'll add a new customer value, and this is the moment of truth. Now let's switch back to the RedPanda topic view and see if our change appeared. At this timestamp, we can see an insert operation with the customer name Alpha Corp. Success. The database change landed in our Kafka-compatible RedPanda cluster in real time. Think of all the possibilities this opens up. You could build event-driven services, set up instant backup systems, create real-time analytic pipelines, or trigger automated workflows. There's plenty of room to play with this technology. Before we wrap up this demonstration, let's explore something really interesting about TiCDC. We're going to scale out our TiCDC setup. We'll clone our configuration, spin up a second TiCDC node, and see what changes in our system behavior. Using the scale-out process again, we can add another TiCDC instance to our cluster. Now if we run our list command again, we can see that two TiCDC instances are now sharing the invoices to RedPanda change feed. What do you think happens if we insert another row into our database? Place your bets before we find out. Let's insert another record with a different customer name. Now let's refresh our RedPanda topic view and see what happened. We can see that only one new record appeared in the topic. The TiCDC cluster coordinates flawlessly with no duplicate records, even though we have two TiCDC nodes running. This shows the built-in coordination and load balancing capabilities of TiCDC. Now let's test the high availability aspect. What happens if we remove the original TiCDC instance? The second one should keep the change stream alive as if nothing happened. Let's delete the first TiCDC component from our cluster. Now, if we run the list command on the second server, we can see that the change stream is still healthy and running. The first server, of course, will time out when we try to query it because we removed that component entirely. One last test to demonstrate the completeness of our change capture. Let's run an update operation instead of an insert. We'll modify an existing record in our invoices table. Back in the RedPanda topic, we should see a single update event appear, exactly as expected. The system captures all types of database operations, not just inserts. This demonstrates that TiCDC successfully captures and streams all database changes, including inserts, updates, and deletes, providing a complete audit trail and real-time data streaming capability. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.